Hey guys, so in this screencast we shall discuss vectors, the resolution of forces under vectors. So in this case, we have been given this this problem. So we have been asked to come up with a resultant force, the resultant force Fr, and the direction theta. So the direction of the resultant force theta. So in this case, to come up with a a resultant force and to come up with a resultant force and the direction, we need to resolve these forces into components. So we shall use the method of components of resolving the forces, each and every force into the x and y components. So in this case, we shall resolve all the forces into components. So now to come up with the resultant force, what we need to come up with the summation of the forces in the x, the summation of the components of the forces in the x, and the summation of the forces of the components in the y. So in other words, what I'm saying is we need to come up with the value of the summation of Frx, uh, and at the same time we need to come up with a summation of Fry. So after that, we are going to use this formula Fr to come up with a resultant force. Fr is equal to the root of summation of forces in the x squared plus summation of forces in the y squared. So this is the formula that we shall use to determine the resultant. Then to come up with the direction of the resultant, which is theta, going to say theta is equal to tan inverse summation of forces in the y over summation of forces summation of forces in the y over summation of forces in the x, summation of forces in the x. So then we'll come up with a value of theta. So in other words, what we are saying is after resolving these forces into components, we must come up with this. On the x or y plane, we do have this. We do have this as the x, and we do have this as the y. So what we are coming up with is the resultant force. Here we have getting Fr. Then here we have Frx. Here we have Fry. So the angle theta that we are talking about is this. So the angle theta that we are talking about is that. So in this case, to come up with a resultant force using this method, we know that this line here, is parallel to this line that I'm drawing here. So it is parallel to that. So in other words, if it is parallel, then we can say what is in this line is the same as what is in this line. So in this case, we are saying we do have this line. Here we have theta. Then here we do have summation of f. I mean we have got Fry. Then here we have got FRX. So it's just to show you where this is coming from, where this is coming from. So now, using the concepts that we already know that if we have got a right angle triangle, if we have got a right angle triangle like this, to come up with the value of the component FR, it is the same as doing the Pythagoras theorem, which we did here. So this is where it is coming from. So we just perform the Pythagoras theorem, and where we have been asked to calculate theta, we know that this line here is the opposite, and this is the adjacent. So from there we know that tan theta is equal to opposite over the adjacent. So we are going to use this approach to come up with a resultant force and the its direction. So we go back to the question. What does the question demand? So the question demands. So what does this question demand? So we have got those forces. So we have got those forces. We do have the 150 newtons pointing in the it is in the west north direction. So we do have the 120. It is between the east and the north. 80 is between north and east again. So let us resolve this. So I'm going to redraw this. So I shall redraw this. So just an FBD. So a free body diagram. I'm going to use this free body diagram. So I have got this. I've got these forces. Okay, this is my. Let me put this as my y-axis. This is my y-axis. Then I've got this as well. At the same time, I've got this. So this is the x. So using this, we do have so this is 13. Okay. So this is 13. So this is, I've got this angle. So this is 40. So I've got a 40 here. Then also have so 30, 35 there. So this is 30, and this is 35 here. So here I've got the 80 Newton force. Then here I've got the 120 Newton force. Then from there, what do I have again? So this force is 150. Okay. So I've got the 150 Newton force there, 150. So I've got this as my 150 Newton force. So let me redraw this a bit. So this is my y-axis. So having this, having this, having this, I'm sure we can now resolve this into. Can now resolve this into. We can now resolve this into components. Can now resolve this into components. So resolving this into components. Messages again. So resolving this into components. And what are we getting? So what we are getting is so let us first start by resolving the resolving into the x component. This into the x component. So we say summation of forces in the x. What do we get? So we do get. What do we get? So what we are getting is. So we have got there we have got we have got the 80, 120 and 150. So now what we must pay attention to is the directions again, the direction. When we resolve it into a component, is it in the negative direction or the positive direction? So I'm starting with a 40. So I mean with the 40, I mean the 80 newtons, with an angle of 40 degrees with respect to the x. So in this case, what I'm going to do is I know that using the I've got this force which is 80 newtons. Here the angle is 40 with respect to the x-axis. So if I was to resolve this into the x component, then it is just I am going to use the cos the cos. So cos will be used in this case since the x component is the adjacent. So since the x component is the adjacent, I'm going to use cos. So in this case, we are saying we have got 18. So now it is going again in the positive direction when I resolve it. When I resolve this 80 newtons, it will be in the positive direction. So I'm getting. So what I'm getting is I'm getting cos. I'm getting cos 40. So it is cos 40. So cos 40 plus. So cos 40 plus. So again, when we go back, we have got this 120. So now this 120, we need to be very careful. So the 120 Newton force, the total angle, we need to add these two. So we need to add the 30 and the 40. So we need to add the 40 and the 30. So that's what we must do. So 40 plus 30 is 70. So in this case, we are getting 120 cos 70 plus we have reached here. So we are on the 150. So 150. So if we are to resolve this 150, so this 150 is like this. So it is like this. So we have got this angle here. So the angle is 35. So we have got a 35 here. Then we have got a 150 newtons here. So in this case, if we are to resolve this into the x component, then we are taking this adjacent. We are looking for this adjacent, and for us to have this adjacent, we must use what? Cos, because cos theta is equal to adjacent over hypotenuse. So it is adjacent over hypotenuse. So now if we make the subject adjacent, so we are saying adjacent is equal to 150 cos 35. So it will be 150 cos 35 there. So we have got so we have 150. We have 150 sorry, outline. So we have got plus 150 plus 150 cos 45. So 150 cos, cos 35. So 150 cos 35. So there we have got 150 cos 35 cos 35. So but it is supposed to be negative. If we observe this very well, when we resolve it, it is going in this direction, so it is going in the negative direction. So it is going in the negative direction. So here we must add the negative sign to show that the component is pointing in the negative direction. So adding this, what are we getting? So it's a matter of using the calculator now. So we are getting we have 8 equals 40 plus 120 equals 70 minus 150 equals 35. So what we are getting is we are getting so what we are getting is we are getting so we are getting so we have 8 equals 40 plus 120. 8 equals 40 plus 120 equals 70 minus 150 equals 35. Yeah, so what we must get is negative 20.546 newtons. So this is in the just in the x. So this is just in the x. So now we can go to the y component. So now let us get the one for y. So the resultant in the y. So for the resultant in the y, what we must get is FRY is equal to, so FRY is equal to, so now if we are to get the x component, the y component for this 80 newtons, I'm sure it is positioned like this on the diagram. So it is in this position on the diagram. So we have got this 40 degrees angle here. Then we have got the 80 newtons. Then this is the x-axis. So now we are looking for this side. We are looking for Fy. So to come up with Fy, we know that this is the opposite. So we are looking for the opposite. So when looking for the opposite, the sign applicable there is so the trig ratio applicable there is the sign ratio. So it is the sign ratio. So we are saying it is 80. So it is 80 sine 40. So now where is it pointing? So it is pointing in the positive direction. So there is no need to add a negative there. So we are saying what we want now is 18 sine 14. So we have got 80 sine 40 there plus so we move to 120 to the 120 Newton force. So now for the 120 Newton force, like I said, we are taking consideration of both angles, the 40 and the 30, because for us to count that it is an angle indeed, it must start from the x-axis up to the force itself. So now from the x-axis up to this force, there we are making an angle of 70. So there we are saying we have got 70 in. Then this is 120 newtons. Here we have got the x-axis. So we have got the x-axis. So we are looking for this side. So that side is the opposite. So since it is the opposite, and when we have got the opposite, so when we have got the opposite of 120 newtons here, and we are looking, we have got the hypotenuse of 120 newtons here, and we are looking for this opposite. So the trig ratio applicable there is the sine ratio. So it is the sine ratio. So we are going to say it is 120. So it is 120 sine. So it is 120 sine 17 plus um we do have so after that we do have this 150 Newton force. So we do have this 150 Newton force. So the 150 Newton force there. So for the 150 Newton force there, so it is in this direction. So we do have this. So this is 150 Newtons force. Here the angle from the negative x-axis we have got 35 degrees. So 35 degrees. This is the x-axis. So what we want is we are looking for this component in the y. We are looking for that component in the y-axis. So to look for this component fy in the y direction, we are taking the opposite because we have the hypotenuse of 150 newtons, and what we want is the opposite. So to get the opposite, the trig ratio applicable there is the sine ratio. So it is the sine ratio. So we are saying so again this is pointing in the positive direction. So it is pointing in the positive direction, like as you can see. So we are saying we are saying the component there is 150 sine. So the component there is 150 sine sine what? So it is 150 sine 35. So 150 sine 35 there. So it is 150 sine 35. So we can add to come up with with your with a single digit. So we get 80 sine 40 plus 120 sine 70 plus 150 sine 33 plus 150 sine 33. So what we get is not sine 33 but sine 35. So 80 sine 40 plus 120 sine 70 plus 150 sine 35 sine 35. So let me just correct this. It is not visible. Our board is very small. So this is simply 150 sine. So 150. Oh, I can maybe write it on. So 150 sine. So plus 150 sine 35. So we are getting this as our answer. So this is just 250.22 25 newtons. So this is what we are getting. So now we have these two components in the x and in the y. So the next thing that I'll do is I add the x component as negative. So in this case, my x component is in this direction, in the negative, and my y component is in the positive direction, as you can see. So I have got my y as 250. So my F RY here is simply equal to, so is simply equal to so let me do this. I just need to draw a small diagram here. So my FRY is equal to, so it is equal to 250.2225 newtons. That is my FRY. Then my FRX is equal to, so it was equal to negative 20, but since it is pointing in the negative direction, I've already said that if it is pointing in the negative direction, you must point the arrow, like I have pointed here, in the negative direction. So there is no need to include to include the sign. So instead, I will just put 20.546. So I will just put 20.546 newtons as my X. So what I'm looking for is the resultant. So my resultant force will come out as this. So we have got this as FRY. I've got this as FRY. So that as my FRY. So since this is my FRY, then the angle that I'm looking for, the direction, so it must be with respect to the X. So I'm looking for this as theta. So I'm looking for these two now. I've got this and I've got this. So theta with respect to the negative x-axis and the resultant force there. So to come up with a resultant force, so the resultant force is always positive. So what will show where the direction of the resultant is pointing is the angle that we are going to find, theta. So in this case, to come up with the resultant force, what we must do is we know that there we are applying Pythagoras theorem. So we are applying Pythagoras theorem. So using Pythagoras theorem, we have got 20.5. I've got 20.5. I've got 20.5. 5. I'll just put 20.55 squared plus 250. 250.22 squared. 0.22 squared. So then our resultant force is equal to, so I've got 20.55 squared plus 250.22 squared. So the square root of this we are getting, so we are getting 251.06 newtons. So this is the answer that we are getting. Then what of theta? So theta is equal to tan inverse. So it is equal to the y component, which is 250.22, over the x component of 20.55. So what are we getting as theta? So theta is equal to 250.55.22 divide 20.55. Then the tan inverse answer. So we are getting 85.3 degrees. So in this case we have got FR. So we have got this. So what we have gotten is we have gotten this. I've gotten this. This was 250 point. We have gotten this. So Fy is equal to 250 250.22. Here we have 20.55 newtons as Fx. Then Fr, our Fr is 251.06 newtons. Then the direction, which is theta. So our theta is equal to 85.3 degrees. So from the negative x-axis, as you can see, so we have got the direction of 85. So direction is 85.3 degrees from the negative x-axis. As you can see, this is the negative x-axis. Then we have got the resultant force of 251. So here ends our problem. So if you are given a question like that, you have been asked to 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 come up with a resultant force and the direction. So you first of all resolve the forces into their components. Um, then using that, you perform the Pythagoras theorem. You do the Pythagoras theorem. Then from the Pythagoras theorem, you use the tan ratio to determine the direction. So then you have managed to answer the problem. So thank you so much, and have a blessed day.